Hi, it's Mrs. Moret with your homework help on today's assignment. And sorry, I had a thing on my screen. All right, so the Unit 5 Lesson 2 practice problems. Here we go. Number 1, the thermostat in an empty apartment is set to 65 degrees Fahrenheit from 4 to 5 p.m. or 4 a.m. to 5 p.m. and to 50 degrees from 5 p.m. until 4 a.m. Here's a graph of the function h. That gives the temperature h of x in degrees Fahrenheit in the apartment x hours after midnight. So here's where it's still set to 50 degrees, and it increases up to 65, stays there, and decreases back to 50 degrees. So that's h of x. Now we have a new schedule for part A. They set the thermostat to change 3 hours later in the morning and in the evening. So that means if we sketch this and we call it G as a function of time. So right here where the temperature increases, instead of at 4 a.m., 1, 2, 3, it's going to increase at 7 a.m. And assuming it takes the same amount of time to heat up, it'll reach temperature then at 9 a.m. And then when it goes to go back to 50 degrees, it will also be 3 hours later. So 1, 2, 3. And then it would reach the 50 degrees 1, 2, 3 hours later. Okay, so our second function, g of x, being 3 hours later at each point, would look like that. So this is a change to the input. The output has stayed the same. Okay, so it's just a change to the input. So explain what h, so h is the original function, h of 6.5 equals 65 means in this context. Why is this a reasonable value for the function? Okay, so what it means is that at 6:30, right, because 6.5 hours past midnight, at 6:30 a.m., the temperature is at 65. It's a reasonable value because 6.5 means 6:30 a.m., which is a real amount of time. Okay, and then part C, if h of 6.5 equals 65, that's what we just did. Oh, I should have said degrees Fahrenheit. Then what is the corresponding point on the graph of G? Use function notation to describe the point on the graph of G. So it would be just 3 hours later, right? Because function G changes 3 hours later in the morning and the evening. So in 3 hours later, which is, I'm just going to kind of write a little note here, 3 hours later is 9:30 a.m. Okay, so using function notation, we would say G of 9.5, right? 9:30 is 9.5 hours past midnight. And so G of 9.5 equals 65. So that would be the corresponding point for graph G. And then finally, write an expression for G in terms of H. Okay, so it's 3 hours later, and it's a shift of 3 to the right on the graph. So remember, we use the opposite sign for an input change. And so that tells me that G of x is equal to h of, and it's a change to the input, right? Not to the output. So it's going to be in the parentheses, x minus 3. Okay? So what this means then is that, like, this G of 9.5, it's equal to h of 6.5, right? 3 hours difference. All right, let's look at number 2. It's a story problem about baking a pie. It says a pumpkin pie recipe says to bake the pie at 425 degrees for 15 minutes, and then to adjust the temperature down to 350 degrees for 45 additional minutes. The function P gives the oven temperature setting, P of T, in degrees Fahrenheit, T minutes after the pie is placed in the oven. So explain what P of 30 equals 350 means in this context. So time is in minutes, and so P of 30 means after 30 minutes. The temperature is set at 350. Degrees Fahrenheit. Okay, after 30 minutes, the temperature is at 350 degrees Fahrenheit. All right, now in part B, Diego discovers that the temperature inside the oven is always 25 degrees warmer than the oven's temperature setting. The function B gives the actual temperature of Diego's oven. Okay, if P of 30 equals 350, what is the corresponding point on the function B? All right, so let's think about this. The temperature is the output. So this 25 degrees warmer, that's an output change, not an input change, right? So what that tells me is that in function B, that what's actually happening in the oven after 30 minutes is it's not at 350 degrees. It's 25 degrees warmer. So see how I added that 25 to the output. So for function B, B of 30 is equal to 375. Okay, so then writing that using function notation, again, this is an output shift, and so we're going to see that plus 25 on the outside of the parentheses because it's an output change, not an input change. The input is time, and the output is temperature. So B of T is equal to P of T, what they thought was happening in the oven, but actually it's 25 degrees warmer, so plus 25 to the output. Right, number 3, we get to do some sketching on number 3 and without a grid, so just do my best there. So here is the graph for y equals f of x, so this is the f of x. On the same axis, sketch a graph of g of x, which is f of x plus 2. That plus 2 is an output shift, and so we're going to move each of the points up 2 places. So here's the vertex, and if I move it up 2, it's about here. So this is going to be for g of x. And then this little intercept, moving it up 2, is about there. And this one is right about there. And so then we have this graph like that. This is really hard for me to draw without a grid, but that's the best I can do. This is g of x. And then we're going to do one more for h of x, which is going to have an input shift, right? The x plus 2. It's going to be f of x plus 2. And so I'm going to take each of these points, and for h of x, it's going to be to the left 2 places. All right, so that means the vertex is going to be about here, and then this root will be about here, and this one, will be about here. And so here's that. That's a horizontal shift. And that's h of x. Okay. So part C, how do the graphs of H or G and H compare to F? So graph G was shifted up 2 units. and graph H was shifted to the left 2 units. Okay. Oh my goodness, my drawings don't look very good, but it's okay. All right, moving on. Number 4. The graph shows the height of a tennis ball t seconds after it has been hit. And so here's the function f. F of t equals 5 plus 30t minus 32t squared. It models the height of the ball in feet. All right, how high was the ball when it was hit? Well, it appears to be at a height of 5 feet. And where do you see this in the equation? Right there, it's the constant. Okay, suppose the second ball follows the same trajectory, but is hit from 7 feet off the ground. So if it was hit from a height of 7 instead of a height of 5, each part of this graph would just be 2 places above what we see right now. So about there, and then this would be about here. And so we would have something like that. Okay, write an equation for function g that defines the height g of t in feet of the second ball hit from 7 feet off the ground in terms of f of t. So the original function is f of t, and so our new function is g of t, and it's an output change of plus 2, right? 2 started from 2 feet higher, so everything is shifted up 2. So we can say then that g of t equals f of t, the original function, plus 2. All right, and then finally, number 5, describe a horizontal translation of the line that contains the 2 labeled points. So to get from the line containing these, let me just draw this line. Okay. So to starting at the line that's already drawn to have a horizontal translation and end up on this line, I'm just going to match it up. It's from this point here, and it's to the left 8 units. And then the vertical translation, you could do a vertical translation. So I'm going to match that same point up with this point down here. And that would be up, looks like 1, 2, 3, 4 units. So performing either of those transformations would start with the line drawn and end with the line I just drew in yellow. So that is the end of your assignment. I hope the video was helpful.